In the summer of 2020, the University of Illinois at Urbana-Champaign hosted an online engineering camp. In the first week, campers were exposed to various types of engineering to help them discover the field in which they were most interested. In week 2, the campers took a deeper dive into 3 types of engineering of their choice. This video covers each of the 12 types of engineering from the first week of the camp. The goal of the aerospace activity was to assemble the glider kit and see how launch angle and launch height affect flight duration and distance. For my experiment, I kept the launch height constant and changed the launch angle. From this, I drew the logical conclusion that increasing the launch angle will increase the flight duration and distance traveled. In the agricultural activity, campers were instructed to build a mini hydraulic excavator and discover how hydraulics work. The word hydraulic means water pipe. Thusly, hydraulic machines push water through pipes, and in this case, syringes, to move. The goal of the bioengineering activity was to track points on a human body performing a dance routine. Between technical difficulties and my lack of dance skills, I did not complete the body tracking activity. However, I decided to construct the paper microscope which was to be used in week 2. I observed dust particles from my phone and strands from my shirt. The first activity of chemical engineering was to make Oobleck. This was done by mixing cornstarch and water in a 2-to-1 ratio. The result is a non-Newtonian fluid, which means that Oobleck does not have a constant viscosity. Rather, it is dependent upon stress. The next activity was making slime. Slime is made by mixing the chemical compound borax with water and Elmer's glue. And why not add a little food dye? Stir the mixture until it is firm. Turns out, slime is a very bouncy substance. The first activity of civil and environmental engineering was to test the quality of water. I collected a sample from my kitchen sink and conducted the alkalinity, pH, hardness, iron, chlorine, copper, nitrite, and nitrate tests. Luckily, my kitchen sink water is safe in every aspect. The water has the perfect acidity, hardness, color, and it won't corrode pipes or irritate skin. The next activity was to build a tensegrity structure. A tensegrity structure is one that uses tension to support itself. These structures have been used to make bridges, towers, and art sculptures. This activity was rather challenging, but fascinating nonetheless. The goal of the computer engineering activity was to use an Arduino board to create a light that is touch activated. Thanks to the thorough instructions, this project came together a lot easier than I had expected. There were a handful of computer science games that explained how a series of inputs yields a specific output. For this card trick, Player 1 will deal a grid of cards with some cards facing up and some facing down at random. Then Player 2 will add a border of cards such that there are an even number of cards in each row and column. Player 2 covers their eyes while Player 1 flips a card over. Player 2 will instantly know which card was flipped because that card will be in a row and column with an odd number of cards face side up. For electrical engineering, there was a card game that taught the players about algorithms. The goal was for Player 1 to sort the letters into the correct permutation by asking Player 2 a series of yes-no questions. For the first round, I had no strategy but still managed to get the correct permutation. For the second round, I began to form a strategy, and in the third round, I fully implemented my system of sorting letters. I would carry one letter down the line until I found its proper position in the word, then I would start back at the top and repeat. The The goal of the industrial and enterprise systems engineering activity was to design 3 different houses and try to make them affordable and carbon negative. All of my houses were very small and had the maximum number of solar panels attached. I added a lot of windows and most of my houses were carbon negative. There were 3 activities for material science and engineering. The first was to grow a crystal from a potassium alum solution. After letting boiling water and potassium alum sit for 24 hours, campers had to remove the largest seed crystal and suspend it in the solution for another week using a copper wire and popsicle stick. The next activity was observing how the properties of Orbeez change in tap water and salt water. After 24 hours, the Orbeez had increased diameter, become squishy, and were able to bounce higher. The final activity was discovering how a gummy worm changes properties in tap water, salt water, and sugar water. The gummy in tap water became more squishy and lost its structure. The saltwater gummy shrank into a disgustingly firm blob. The gummy in sugar water became more squishy but retained its structure. The goal of the mechanical engineering activity was to build a machine that could lift a small weight using mechanical advantage. We were supposed to activate the machine using nitinol strings, which constrict when heated. However, my system struggled to lift the weight, so let's just pretend that it worked miraculously. The nuclear engineering activity was meant to demonstrate how static electricity interacts with conductors and insulators. Campers were instructed to build a structure that suspends an aluminum foil ball next to an aluminum pie pan. We then had to charge a plastic plate and set the pie tin on the plate, thus causing the aluminum ball to push away from the tin. Unfortunately, I accidentally grounded the plate, so there was no effect on the foil ball. Overall, I enjoyed exploring the many types of engineering at the University of Illinois summer camp. All the activities were fascinating, entertaining, and educational. To learn more about what happened in week 2 of the camp, check out my video which covers additional activities from mechanical, aerospace, and electrical engineering.